This lesson is titled Proportional Relationships and Equations. We have talked about proportional relationships with tables and proportional relationships related to graphs. But now we're going to look at how equations can also be used to describe proportional relationships. Whenever we have an equation and it's representing a proportional relationship, we know that it will be in this format. Y equals m times x, where m is the constant of proportionality. We know this because the constant of proportionality is our constant multiple. And when we have a proportional relationship, we always have a constant multiple. We're always multiplying by the same number. So this equation is always telling you to multiply by that number. Just as a reminder, the constant multiple is the same as the constant of proportionality, which is also the same as the unit rate. And we know this is always y over x. And now in our example here of an equation that represents a constant proportionality, this value will be used, we'll use the variable m for. Just a special variable that we always use for this special number. Since the value of y depends on the value of x, y is the dependent variable and x is the independent variable. We've talked about that before, dv over iv. Your friend uses the equation y equals 8.5x to calculate the total cost y in dollars for x movie tickets. What is the constant of proportionality shown in the equation? The constant of proportionality, remember, is always the same as the constant multiple. So looking at our equation, what are we always told to multiply by? 8.5 is our constant of proportionality. We know that the constant of proportionality is always the same as the unit rate. So 8.5 is our unit rate. So in the context of this problem, it's telling us the price for one ticket. Since we know the unit rate, we can easily calculate how much 13 movie tickets will cost. We simply need to multiply by 13. We can use a calculator to help us, just to speed things up. $110.50. So that is the answer to part C. The equation P equals 4S represents the perimeter P of a square with side length S. What is the constant of proportionality? The constant of proportionality is always your constant multiple. So looking at this equation, what is it always telling you to multiply by? The constant of proportionality is 4. Remember that we can use the variable m to represent constant proportionality rather than writing out the word. What is the perimeter of a square with side length 1.6? Well, our equation is telling us that we always multiply by 4. So we would take 1.6 and multiply by 4. We can also use the format of the equation to help us solve the problem. but 1.6 times 4. We'll just do that over here to the side. The parameter will be 6.4, and we can label that as meters. Sometimes we may have a situation and we want to write an equation to represent that situation. If we're dealing with a proportional relationship, we can just use the constant of proportionality and write our equation in the form of y equals m times x, where m would be some number that we know as our constant of proportionality. So we need to think about what our constant of proportionality would be. Now, the good thing to keep in mind with these situations or these problems is that the constant of proportionality is the same as the unit rate. So if we could find the unit rate for these situations, we can easily write the equation. A certain vegetable dip contains 60 calories per serving. What equation represents the number of calories y in x servings of dip? Well, our unit rate is 60 calories per serving, one serving. So 60 is our unit rate. Let's kind of go through and, well, I guess that one's already available for us. We're ready for it. But we can kind of go through and find each unit rate, and then we can sort out the equations. At a telethon, a volunteer can take 60 calls in 5 hours. What equation represents the number of calls y a volunteer can take in x hours? 60 calls, 5 hours. What's the unit rate? If we find the unit rate, we find the constant of proportionality. That would be 12 calls per hour. Okay, let's do the last one too, and then we'll sort the equations. A machine can make 60 keys in 12 minutes. What equation represents the number of keys y made in x minutes? 60 keys in 12 minutes. We want to find that unit rate. How much for 1 minute? That would be 5. So we can sort our equations. Okay, so this unit rate was 60, this one was 12, this one was 5. We never got 300 as a constant proportionality. We did get 12. We never got 720 as a constant proportionality, but we did get 5. So those unit rates are a constant of proportionality or a constant multiple. So we're picking equations that are showing that we should always multiply by that value. Go ahead and try this one on your own. Make sure that you understand that finding the equation involves finding the constant of proportionality, which we know is always the unit rate. Pause the video and try it out. All right, remember that money is always on top. Money is our dependent variable. If we want to get the unit rate, we want to find out how much for 1 apple. So we would divide by 5. If we take 250 and divide it into 5 evenly, we get 50 cents. So we could write our equation using this constant of proportionality value. The format is always y equals mx, where m is the constant of proportionality. We could even write it without the extra 0. We could just say 0.5x. So this is showing that we always multiply by 0.5 or 50 cents. For however many apples we have, we always multiply by 50 cents, and then we can always find the total cost. Okay, let's go ahead and focus on the last part of our lesson. A proportion is an equation stating that two ratios are equal. You can use a proportion to solve a problem. Solving a proportion is similar to finding an equivalent ratio, which we've done a lot already this year. In the average adult male, for each 5 pounds of body weight, about 3 pounds is water. How much of a 188-pound adult male is water? All right, let's watch and solve.
Previously, you might have tried to find a ratio equivalent to 3 to 5 with a denominator of 188 to solve this problem.
Okay, first let's think about how they set this up. They had put the amount of water on top and the body weight on bottom. And then we're having a new situation with an adult male of 188 pounds total, keeping that weight on bottom, and then we don't know the amount of water. Notice that whenever we start to write a proportion, we want everything to match and line up. We've talked before about how the order that we write our ratios and rates is important. So we need to make sure that as we work with the proportion, we're keeping everything lined up and in order. Water always on top, body weight always on bottom. Now we've done stuff like this before. We're just trying to get from one ratio to the other, and then we can find that missing number. Now, it can be a little tricky with this one because what do you multiply 5 by to get 188? It's not clear and it's not a nice number. So they're going to go through a process of finding this missing number that's a little different from the way we've been working on these.
This time, try using a proportion. Let W equal the number of pounds of water in a 188-pound person. The ratio 3 to 5 represents 3 pounds of water for every 5 pounds of body weight. Now find W so that the ratio W to 188 is equivalent to 3 to 5.
Okay, when we look at this situation, when we focus in on that variable, because that's the missing number we want to find, we see W over 188. Well, this fraction bar also represents a division problem. So we have W divided by 188. We're wanting to kind of work backwards to find that value. So what we can do is the opposite of divide, and we can just multiply by 188 instead. This will help us solve for the missing number.
First, multiply each side of the equation by 188. Finally, simplify the equation.
Okay, notice what's going to happen here. We're doing W times 188 and dividing it by 188. These 188s are going to cancel out. We're just going to have W. That's what we want. We want to find out just what W is.
3 times 188 equals 564. 564 divided by 5 equals 112 and 8/10. About 112 and 8/10 pounds of a 188-pound adult male is water.
Okay, now this isn't the only way to solve this proportion. Remember that we had set it up so that our numbers lined up and we were just trying to find the missing number. We talked before about how you can definitely look for a number to multiply 5 by to get 188. You can actually do 188 divided by 5 to find that number. We would have to multiply by 37.6 on the top and the bottom to follow this pattern and find the missing number. This is a fine way to solve the problem, and you can definitely do it this way if you would like. So we found that W is equal to 112.8. But there's another way that I think most students are most familiar with. If you have a proportion like this, you can use a method called cross multiplication. This is something that students usually are pretty familiar with already. So this is something that I like to continue using. We would multiply diagonally. 5 times W is 5W. 3 times 188, which we can do by hand or we can use our calculator, is 564. Since this is a proportion and these two ratios are equal, their cross products, 5W and 564, should also be equal. Well, since we are having a multiplication problem here, 5W equals 564, we would want to divide by 5